Everybody, we are Daniel Saavedra and Santiago Torres, and today we are going to present the wonders of osmotic pressure and colligative properties and how they apply to real life.
First, let's begin by understanding what is the difference between osmosis and reverse osmosis. Now, the best way to understand osmosis is using an example. In here, we have a U-tube, where in the left we have salt water and on the right fresh water. In the middle we have a semi-permeable membrane. In here the fresh water wants to go to the salty water because it wants to reach an equilibrium between the solvent and the solute.
On the other hand, the reverse osmosis happens when there is a pressure applied in the salty water, pushing it to the other side, and the membrane keeps the salt in the membrane, allowing only the water to pass through.
Now, we would like to talk about the real applications of reverse osmosis in the real life. A real example of reverse osmosis is the process of water purification, where the membrane flat sheet is combined with a feed channel spacer, which creates turbulence in the water and allows the particles to remain in the feed channel spacer. In here, we can see how the feed channel spacer creates turbulence in the water, allowing the water to pass through and the particles remaining in the feed channel spacer. In here, we can see how the dirty water is passing through the filter and the clean water is going through one side and the dirty water is going to continue the process of cleaning the water.
Which are the best materials to construct the membrane for the reverse osmosis water treatment? During the water purification process, the membrane is composed by three different layers: a polyester fabric support layer, a polysphere layer, and a 0.2 micro thick polyimide barrier layer.
Now that we understood how the process works and the materials of the process, why do we use rolled membranes instead of flat membranes? The problem with using a flat membrane is the fact that the obtention of the clean water is very inefficient, given that we would be obtaining small amounts of water every time. By using a rolled membrane, the water is able to flow freely in a spiral way into the central tube, where the clean water goes to one side and the dirty water, or the remainings, go to a different tube to be discarded.
What can we do to improve the process of water purification?
We can increase the number of water purification steps, because each time that the water goes through the purification tube, a percentage of the impure particles present in the water are removed, and every time that the water goes through a different tube, there is a percentage loss of impurity.
After every water purification process, between 70 and 90% of the water can be recovered as pure product water. This is a very high rate of water purification.
Created using Powtoon.